Lecture 10, Presentation 3. Homo erectus, 1.9 megaana to 250,000 years ago, Africa and Eurasia. Debate about whether Homo erectus represents one or multiple species is in part due to two sweet paleontological challenges. Numerous fossils, we've got more than you would expect, and broad geographic distribution. Anatomically modern humans, us, are the only humans with a larger geographic range, and we exhibit strong interspecies variation. Therefore, it is entirely reasonable to argue that Homo erectus, over a greater amount of time, 1,650,000 years versus our tiny 195,000 years on Earth, was capable of developing equivalent degrees of intraspecies variation. It was the first human species known to expand its geographic range beyond the African continent. And let me say something about that. Geographic range expansion is not about standing up one day and saying, oh, I'm going to leave Africa and go to Asia. This would have happened as part of range expansion in the way it does for most mammals. Basically, Homo erectus populations had probably started to overhunt or overuse the foods in their areas, and so they kept pushing their ranges further and further away, and one day groups started to arrive in Asia. Homo erectus originated in East Africa. It appears to have expanded its range across much of Africa. Some populations in the northeast, without intention, expanded northward to the frontier of Europe at southernmost Georgia, and some populations moved eastward into southeast and northerly Asia. Homo erectus was the first hominin with fully facultative modern bipedal adaptations. Their lower skeleton looks exactly like ours. Now, modern bipedal adaptations, or fully facultative bipedal adaptations, weren't required for range expansion, but they sure didn't hurt. The capacity for modern stature would improve stride length and endurance. Hominin bipedalism does not provide the benefits of speed. The majority of quadrupeds can outrun us in a sprint, and I'm sure you've heard the jokes about bears. So there are two guys running away from a bear, and one guy says to the other, "Aren't you worried we're going to get killed by this bear?" And his buddy says, "No, not as long as I can run faster than you." Well, instead, our bipedal adaptations enhance the aptitude for distance travel. We might be slow, but we can walk or gently lope along for hours at a stretch. Think of malls. Malls are miserable in terms of your feet because the floors are all cement. They might have linoleum, but underneath it's nothing but cement. And yet you can walk all day in a mall if the sales are right. For me, if there are shoes involved. Thus, Homo erectus was the first human to experience diverse habitats in a broad array of latitudes, so distance from the equator, in a variety of tropical and non-tropical places over a large amount of time. Homo erectus' average cranial capacity is larger than earlier hominins, but smaller than Homo sapiens. However, cranial capacity range 690 to 1251 cubic centimeters overlaps with all Homo species. Regardless of variation, Homo erectus populations include individuals with sagittal keels. There are other traits that indicate Homo erectus, but this specific trait is easy for us to see when you're just looking at this visually. Asian Homo erectus populations: heartbreak, death, war, and loss. In the late 1880s, Eugene Dubois, a Dutch anatomist, became obsessed with finding the missing link between apes and humans. Like most early paleoanthropologists, Dubois had no idea that human evolution occurred over millions of years or even 1 million years. So, the idea of finding a single missing link between apes and modern humans seemed reasonable. Inspired by Origin of Species, Dubois supported the hypothesis that human origins would be in a tropical place near modern apes. However, instead of considering Africa, Dubois focused on Asia. And remember that he is Dutch. Well, the Dutch colony of Indonesia looked promising because it had a great ape, the orangutan. Dubois resigned from an academic position, enlisted in the Dutch army, and got himself posted to Indonesia, where he began searching for the missing link. Using a prison chain gang, Dubois got his fossil reward in 1891 on the banks of the Solo River in Java, Indonesia. Dubois had recovered the fossilized skull cap of an ancient human. Its brain was smaller than a modern human's brain, and it didn't have a forehead, and it had a unique feature, a sagittal keel. So a sagittal keel lies atop the skull in the same place where you would find a sagittal crest. But the sagittal crest looks like a bony mohawk, and a sagittal keel is more like a speed bump. We know Dubois' specimen by the nickname of Java Man. Dubois gave Java Man a new genus and species identification, Pithecanthropus erectus, upright ape man. His fossil was not well received. By 1911, Piltdown was viewed as the one and only, the legitimate missing link, and as I've already explained, Piltdown was a hoax. Now we recognize that Dubois' Java Man is Homo erectus. Remember that there was no chronometric dating. No one knew that Dubois' Java Man fossil was 650,000 to 600,000 years old in a species that is 1.9 million years old. Heartbreak? Dubois passed away before the importance of his find was recognized by science. In 1919, Canadian anatomist Davidson Black took a teaching position at a medical college in Peking, modern Beijing, in China. In 1921, Black was given 2 fossil human molars from Dragon Bone Hill at Zhaokudian. Dragon bone is the way that traditional medicine made from fossils is referred to. And this is something that we find in parts of Asia. So Dragon Bone Hill, that probably means that this area was mined for fossils for traditional medicines or drugs for quite some time. The limestone cave system at Zhaokudian holds numerous fossil-bearing localities. Under Black's direction, paleontological research began at Zhaokudian. Fossil human remains from the site were identified by Black in 1927 as Sinanthropus pekinensis, nickname Peking Man. Now we recognize that Peking Man is Homo erectus. Zhaokudian yielded numerous Homo erectus specimens. Death? Black died of a heart condition before his 600,000-year-old Peking Man was fully acknowledged. Back to Java. In the 1930s, Dutch paleontologist Ralph von Koenigswald recovered more Java Man fossils. All had sagittal keels. Back to China. German anatomist, another one of my heroes, Franz Weidenreich, took over research at Zhaokudian in 1935. Weidenreich was an outstanding anatomist. In the 1920s, on the basis of anatomy, he identified Piltdown as a hoax, and he was only looking at the cast. Everyone thought that he was crazy, and basically he got kicked out. At Zhaokudian, he collected data, photos, illustrations, and casts on a growing collection of Peking man fossils. By 1937, there were multiple adults and juveniles known from Zhaokudian. Back to Java. In 1937, Weidenreich visited von Königswald in Java. They concluded that Java man and Peking man belonged to a single species. In 1940, Weidenreich named it Homo erectus. War? Japanese military expansion during World War II disrupted research in Indonesia and China. Weidenreich fled to the American Museum of Natural History in New York City, and von Königswald was jailed in a Japanese concentration camp in Indonesia. If not for Weidenreich, all of the Zhaokudian data would have been lost. However, he couldn't save everything. Loss? The original fossils disappeared during World War II. In 1941, the area was under Japanese occupation. Weidenreich had taken casts, photos, and linear data with him, so measurements, with him when he escaped to the American Museum of Natural History. The fossils had been packed up to be sent by ship to New York City. When last seen, they were in transport with the U.S. Marines. Then they disappeared. They have never been recovered. Like Piltdown, the Peking man mystery has never been solved. And I personally think that this would be a great movie starring Tom Hanks, either as Weidenreich or as the sergeant in charge of the Marines. And we won't be able to resolve it, but we could suggest several ways in which the fossils disappeared. Today, we date Asian Homo erectus to 1.6 million years ago to 250,000 years ago. African Homo erectus research, happier times. In 1960, the Leakeys recovered an individual in bed 2, so this is higher in the stratigraphic section, so it's younger in age, at Olduvai Gorge, along with Acheulean stone tools. Note that stratigraphically, bed 2 is higher, younger in age than bed 1. Leakey nicknamed the fossil Chilean man, a term used by the French for Acheulean tool users. Dated at 1.5 million years in age, Chilean man had the sagittal keel of Asian Homo erectus. In the 1970s, Homo erectus fossils were recovered at a number of East African sites. The most interesting specimens come from localities near Lake Turkana in Kenya. Some are on the western side and others are on the eastern side. This 1.8 million year old fossil skull was recovered in 1975. It significantly pushed Homo erectus's age back in time. Then, these fragmented fossils dated to 1.9 million years ago were assigned to Homo erectus. Why? Sagittal keel. Look at where the arrow is. And then, in 1984, on an expedition led by Richard Leakey, Kamoya Kimiyu recovered the spectacular Narukatomi or Turkana youth. It is dated at 1.6 million years ago. Given its geologic age, the individual is remarkably complete. We have a cranium, facial bones, and upper and lower jaws with their teeth, and about 70% of the skeleton. This really is a remarkable specimen. A find like this provides data on biological age at death, cranial capacity, so brain size, and stature. Based on bone maturation and dental eruption, Narukatomi was a young teenager with a cranial capacity of about 880 cubic centimeters and a height of about 5 foot 9 inches if you put feet on it, and an estimated adult stature, had he reached adulthood, of 6 feet. That is outside the height of adult females, so this was probably male. The youngster had a long and lean body. This leads to a question. What is the adaptive advantage of a long-limbed and slender body type? Modern human populations that have inhabited hot thermal temperature zones for many, many, many generations have slender, long-limbed bodies. This provides greater surface area and promotes thermolysis, heat loss. Natural selection would have favored such adaptations in African Homo erectus. But you have to remember, height is a complex topic. Nutrition, health, and activity in childhood will impact stature at adulthood. Genes provide the potential, but environment also contributes to the outcome. Not that long ago, we described all Homo erectus people as long and lean. However, new data indicate that this was not true for all Homo erectus. Some individuals reached their height potential, others did not. Another Lake Turkana specimen, the Illiret skull shown over here on the left, was recovered in 2000. It has been dated to 1.55 million years ago. It is an adult Homo erectus, but is small in size. It has a cranial capacity of only 691 cubic centimeters. Here, the Illiret skull is placed atop the Chilean man skull. In size, Illiret is similar to Homo habilis. Why has it been classified as Homo erectus? It has a sagittal keel, as well as other features associated with Homo erectus. The small-sized adult Illiret skull comes from the same region as the larger-sized Narukatome youth. It is geologically younger in age, but both individuals are Homo erectus. Based on size variation, some assign the specimens to different species, evidence of interspecies variation. Others view size differences as evidence of population intraspecies variation. Which hypothesis should we support? Well, you can go whichever way you like, but for my money, with all Homo taxa or species, size variation is not a valid taxonomic trait. Why? I give you modern human variation. Going from left to right, we can see that one guy is larger than the other guy, that these siblings range in size, and that Jackie Chan and Yao Ming are both very different in stature. Today, we date African Homo erectus to 1.9 million years ago to 300,000 years ago. Now you are ready for Lecture 10, Presentation 4.